positive integer divisor of 12 factorial is chosen at random. The probability that that divisor chosen is a perfect square can be expressed as m over n, where m and n are relatively prime positive integers. What is m plus n? This looks like a probability question, but really, we really need to be thinking about the number theory aspect of this question, right? We have a number 12 factorial, which remember is just the product of all these numbers, right? And we're asking how many, right, out of these divisors, how many are perfect squares? Well, in order to figure out what a perfect square is, remember that, right, a perfect square is a number where if you take the prime factorization, that all of these exponents are even, okay? So for example, the number 36 is a perfect square because we can write 2 squared times 3 squared, which rewrites as 2 times 3 all squared, right? So you can see that in order for a number to be the square of some prime factorization, all of the exponents have to be even themselves, right? Let's take a look then. That means that we need to find the prime factorization of 12 factorial in order to proceed, because then we can figure out which exponents and which primes can form a perfect square divisor of 12 factorial. One way to do that is just to find the prime factorizations of each of these numbers and then combining them all by adding the exponents. I'll show you a slightly better way using Legendre's formula. So given some number n, this just means the number of times some prime p divides n, right, is equal to, well, take n, right, or n factorial, sorry, is just, right, we take n over 2, floor of that, plus n equals 4, n equals 8, and so on, right, and floor all of those. So in this case where n equals 12 is just 12 over 6, and equivalently we can say 12 over 2 is 6, so that's the first term. The next term is just the floor of that number over 2, right? So you can think of repeatedly dividing by 2 and discarding the remainder. So you get 3, then 1, right? We can see that every time we're just dividing by 2 and taking the floor. So you can see that it goes up to this, and then after 1 we get a bunch of zeros, right? So you can see that we just care about these 3 non-zero terms for a total of 10 times 2 divides 12 factorial. In other words, in the prime factorization, we can write 2 to the 10 times some other stuff. And we can repeat that for every prime less than 12, right? We know that 3 divides it into 12 factorial a couple times, then 5, 7, and 11. And notice that no larger prime can possibly divide any number between 1 and 12. So those are the only primes that are in 12 factorial. So we repeat that, right? Notice that for 3, we get 4, right? 12 over 3 is 4, plus 1 is 5. For 5, that's just 2. Notice that 2 is not at least 5, so that's where it ends. 7 is just 1, 11 is just 1, right? So we get that the total is 2 to the 10, 3 to the 5, 5 squared, 7 to the 1, and 11 to the 1. And we're saying some number d divides that number and is a perfect square. So it's of the form 2 to the, let's say 2 to the a times 3 to the b times 5 to the c times 7 to the d times 11 to the e. Maybe d wasn't a good number, but say some number x, right? And what does it mean for one number to divide the other? That means that a has to be chosen between 0 and 10, b has to be chosen between 0 and 5, c has to be chosen between 0 and 2, and so on, right? And you can see that out of these 5 exponents, all of them can only be at most the exponent in the big number 12 factorial. So we conclude that, well, we need these to be true, and a, b, c, d, and e are even. Well, how many numbers are between 0 and n and 10 inclusive that are even? Well, we have 0, 2, 4, 6, 8, and 10, right? So you can see that there are 6 possibilities here. For B, it's just 0, 2, and 4, so that's 3 possibilities. For C, it's 0 or 2 for 2 possibilities. And then D and E both have to be 0, so that gives us 1 possibility for each. And if you multiply all of those out by the, right, we multiply all the disjoint numbers together to get the total number of possibilities for these 5 numbers A, B, C, D, and E, for a total of 36 possible perfect square divisors of 12 factorial. So, and now we say, how do we find the probability? Well, then the probability is just the number of perfect square divisors divided by the total number of divisors, right? Perfect squares or not. Well, then that's the same thing, right? The number of possibilities is just the number of ways to pick A, B, C, D, and E satisfying these conditions. And we don't necessarily require these numbers to be even anymore because we can have any divisor. So you can see that A can be any number from 0 to 10 for, well, 11 possibilities. B can be any number from 0 to 5 for 6. C has 3 possibilities. D has 2, and so does E. So you can see that our answer is 36 over 11 times 6 times 3 times 2 times 2. Notice that 6 times 3 times 2 is 36, so those cancel. So our final probability is just 1 over 11 times 2, 1 over 22, and it's asking for the sum of the numerator and divisor in lowest terms. So our answer is 23, and if we go up here, that's the answer choice E.